This problem, even though we are fitting people in the room, is more useful to think that we are fitting rooms into people, because each person needs a room, not each room needs a person. So we're choosing rooms, and the slots are the people. Here I've set up the slots, one for each individual. And since this is a slot, I've implied that this is a permutation problem. And this is permutation because each individual is distinguishable from each other. For V to be on the 6th floor, that would mean that there are only 6 possibilities for V. And I'm going to fill this out first. If there are 6 possibilities for V, then what's going to be for M? Well, V already took up one room on the 6th floor. M can have any room on the 6th or the 7th floor, but there are only 5 rooms available on the 6th because V already took up one of them. So there's only 10 for M. And then the same logic works for the fact that N cannot take the room that V has or the room that M has. So there's only 9 room for N. And then vice versa down the row. You can just multiply this across, and you'll get the answer for this one. Now, for P and R to be in the same floor, this is actually a multiple scenario. And the two scenario is when P and R are both on 6th floor, and P and R are both on the 7th floor. Here you can't actually do it in one fell swoop because in the 6th floor have a different nature than being on the 7th floor. And here I'll show you what I mean. Here's P and R. Let's say they are both on the 6th floor. Then that's going to mean that this is going to be 6 and 5, because 6th floor has 6 rooms. So P have 6 choice, and then R can't be in the room P is in, so there's 6, 5. And if they're on the 7th floor, this would mean 5 and 4. So the two floors have different nature, and you really have to do them separately. You can't combine them and try to do it all in one series of slots. And then for the rest, it's going to be the same logic I did here, where you have to subtract out the rooms that P and R already has. So M has really 9 possibility, because out of the 11 rooms, he can't take these two. So 9, 8, 7, 6, 5. And same way for the 7th floor. And since they are both on the 6th floor or they are both on the 7th floor, we're going to be adding these two. And then you'll get the answer for this problem. Finally, for the third part, for M to be above S, since there are only 2 floors, that has to mean that M is on the 7th floor and S is on the 6th floor. For M to be on the 7th floor, there are 5 possibilities. For S to be on the 6th floor, there are 6 possibilities. And notice these two does not conflict with each other, so M can take any of the 5 room on the 7th floor. S can take any of the 6 room on the 6th floor. And then the rest of the logic works the same. Again, 9 rooms because N can't have either of these two but anything else. So 9, 8, 7, 6, 5. And then you multiply this across, and that's it. If this is not completely clear to you, I actually have a video called Slot Workout in the quick tip section. So you can go check that out. That gives a way more detailed explanation of how slots should work.